Hello everyone, this is going to be a quick video, and it's going to be a quick video because I told myself I was going to film a maths video for you guys, and I have so much work to do, so I haven't really planned this out, but I'm going to do it for you guys anyway in like one take or whatever. I'm not doing this again because I don't want to. So, today's lesson will be about inverse functions. And why is it about inverse functions? It's because in lesson we were doing like inverse trig functions, and we had to draw the graph for the inverse trig functions, okay? And if you didn't realize, that was pretty confusing for me. I was like, why do you even need to reflect it around the y equals x line to get the inverse function? And this works for exponential logarithms too. So with an exponential graph, so if you have y equals e to the x, I'm gonna show you guys right now. I'm going to plot it in a new Desmos. Okay. Okay, you can see that, hopefully. Y equals e to the x. So here we have an exponential curve. We love exponentials. Anyways, if you reflect it along the y equals x, you'll get the inverse of this function, which is y equals ln x. And that's cool, isn't it? If you wanna check. It's literally a reflection along the y equals x. And we did this with trigonometric functions too. I will show you on another Desmos webpage. So let's use sine x, because why not? So the inverse of this will be arc sine x. And as you can see, that is literally... it's a bit hard to film this, but it's literally just a reflection along the y equals x line. And the reason it stops here is because for a function to be valid when inversing it like this, it can only output one value when you input a single value. Because if you input a single value and it can result in multiple outputs, then that's literally not the definition of your function. So your function has to be many to one, or it has to be one to one, but it can't be one to many. Meaning, if you put one input, you can't have multiple outputs. Okay, so that's why it's bounded to minus pi over 2 and pi over 2, which are these two peaks and troughs. And the reason is because the domain and range are swapped. Yeah, don't ask me to explain that. I don't know. When you reflect along the y equals x, that's just what happens. Anyways, so those are examples of reflecting along the y equals x and getting the inverse function. But why does that actually work? So I asked my teacher this question, and we didn't even have a discussion. He literally just gave me a one-sentence answer. And it's because if you think about an inverse function, let's have y equals 3x minus 1 as our function, as our equation or function, whatever. If we set, you know how to calculate inverse functions, you swap the variables. So y equals 3y minus 1. But instead, let's actually rearrange that to make y the subject again. So you'll get 3y equals x plus 1, and then divide by 3 on both sides. You'll get this equation, which, if you see here, is reflected along the y equals x axis. That's not an axis, what am I on about? Reflected on the y equals x line. And that's because, if you think about what we're doing when we're reflecting on the y equals x line, is we're literally just changing the variables. And that's how an inverse function works. Because with an inverse function, let's say f of x, you're putting in x and getting out y. But if you're swapping the variables, you're putting in y to get your initial variable, your initial input, x. And that is why, it's not a conclusive proof or anything, but very interesting for me to find this out. And that is why you can get an inverse function by reflecting along the y equals x axis. So I hope you enjoyed my very raw video. Alhamdulillah, there's no one here, I'm on my own. And I'm actually going to get some work done because I have so much work to do. It's absolutely insane. Okay, I'll see you back for another war video sometime next week, probably. Assalamu alaikum.